Okay.
So how was Seoul?
Mixed bag.
Mixed bag.
Good, good, bad, and bogus. It was very nice of Gary Nolan to invite me, and I was not intending to go. It's more synchronicity. It's more evidence for that the non-human intelligences, the time travelers from the future,
Retro causality.
yeah, the retrocausality is working because what happened was that I was in London up until this Wednesday, a few days ago, and we were going to come back in December 3rd, but some business things with my lady friend here, we had to quickly change, come back sooner for business financial issues. And then it turns out that the meeting, the Seoul meeting, is at Fort Mason, which is right down the street from where I live anyway.
Oh, okay.
And it's a place where the Goody Cafe, they have the really good scones. And we often go there. It's just for morning coffee. So I was there for morning coffee, and who shows up in an Uber but Gary Nolan?
Huh, no kidding.
Yeah, and then I said, "Oh, Gary," and I kind of knew that I didn't know exactly where the meeting was. I knew it was somewhere around there, and then I said, "Well, Gary, I'm going to be probably going to be Donald Trump's main point man for all things UFO." So I guess maybe I should come to this thing. And he said yes, and he gave me a ticket, free ticket.
That's
Uh,
very nice of him. Now, have you
yeah,
two
very
met
nice,
before then?
very nice of him. Very nice of him. And there were a lot of good things there, and some things not so good, But it definitely was worth the 2 days, and in particular, in terms of our trip, with the physics of the UFOs. Um, there's a woman, Maria. I forget her last name. She's Romanian. She's one of the main Soul organizers. She's a very beautiful lady, and she's I guess she's a successful venture. She's like Gary. I guess she has some kind of she's created companies.
Is she the one setting up that time travelers conference over in Italy?
No, 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 no. No. That's you got that wrong. That's
Okay.
Poland. It's not it. It's Russia. It's Moscow.
Oh, is that where it's happening?
And the new thing I'm trying. Well, okay. Wait. Let me
Okay,
stay on
okay.
track here because I mean, that's interesting what you said, but it's not really what I'm talking about right now. So now I forgot my train of thought. No. Oh yeah. So she is. No. She is. She works directly with Gary Nolan with the Soul. She's one of like the big shots, the Soul Foundation.
Okay.
But she lives in Madrid. She, came over,
Okay.
and the point is she knows physics. She knows the math. She knows like the Dirac equation. Okay, and so I don't know what her full background is. She's from Romania, but I showed her Einstein's equation, which she was familiar with, and with the G over C. But you're in the way. Get show. Oh no, put K right. Change K. Change it to K. G over C to the four.
Yeah, G over C to the fourth is down here.
I can't see that though. They can't. It's too. It's too. You have. It's. You can't see it. It's too
Okay.
light. Make it dark.
Is that better?
Good. Yes. Good. Good. So in any case, so I showed her that, and I said to her, and there were witnesses all about it. People, gathered around. I attract a crowd, right? And so I said, well, why should it be inside matter with T, with a stress energy tensor, is only inside matter? Why should you use the vacuum speed of light? She used the speed of light. If you're going to use anything, the speed of light inside matter. And of course, you can make that very small. She practically had an orgasm. Yeah, it's just beside myself. Because she's very smart. She
Understood.
instantly saw what I saw, and she went crazy. I mean, she's expressed. She's like an Italian. The Romanians are like Italians, like me, And she got it in an instant. It was like an epiphany. It was like Saul of Tarsus falling off the ass and getting becoming Paul.
Yeah,
She
'cause
saw immediately what it was. I didn't have to. She got it. She grokked it right away. Whereas in most of the other physicists, they come up with stupid, objections to it. That's the basic idea. So that was good. That was good. One of the bad things is this asshole, even though not a complete asshole, physicist from CERN, very glib. I wasn't sure if he's transgender or she. I couldn't tell exactly what. I could long hair with the pink, sort of like I couldn't tell exactly what. I think it was a man, and smart guy. He knows his physics. He knows he's a particle physicist at CERN, and of course everything that he said about mainstream physics is correct, of course, and he
because
knows
of
what
the
he's talking
mainstream.
about. But he's an arrogant son of a bitch, and he at one point, he's in with this audience, and I think he was sort of doing it deliberately. He said, "Well, you may not like what I'm going to say." He knew he was with a bunch of UFO believers, so right away, the first thing he does, he says, "Forget the paranormal, dissociate the paranormal from the UFOs," which of course is stupid, And he said, "Because there's no physics to the concept, nobody understands." Of course, he does. He doesn't know he doesn't know what he's wrong there. He said,
Because there's the back reaction.
he doesn't know any of that stuff. What he knows is standard consensus, safe, mainstream. He doesn't know anything that's really happening competently at the front.
I think
He
called
doesn't
the
know that.
standard Lagrangian of particle physics is what.
And he's probably an experimental physicist. I doubt very much that he's a theoretical physicist. And then finally he got to, and he did say, all the stuff that Kevin Knuth says, well, how much energy would be required, assuming it was ordinary motion, not warp drive. And he correctly basically reproduced the data of Kenneth Knuth and those guys, that requires so many, 100 milliwatts and, this and that. And it's okay. What he was showing is that it can't be ordinary motion. It's got to be warp drive.
Yeah, it can't be Newtonian.
He finally gets to the warp drive. He's not stupid. An asshole, but he's and he finally gets to the warp drive, and then he says the standard thing, which is correct, is it takes too much energy. You can't do it because he doesn't know what I'm doing. All right. So I don't think I had a chance to actually talk to him afterward that we solved the energy. And I never got a chance with so many people. Oh, by the way, what I can't say, but there were a lot of people there, hundreds of people, maybe 1,000. I don't know. The whole auditorium was full.
It was a big event.
These people paid $2,000 each, and some paid $25,000. So they're making good money. Okay. And they had like an army of security. There was plenty of security. It was like I expected them to be walking around with AK-47s. Now, okay, but I did meet some good people. Met some good people. In particular, I met James Fox. The Phenomena, where he showed the movie Phenomenon.
Yep.
But even more important than James Fox is I met Ron James.
Yes.
Ron James, the guy, the Accidental Truth.
I just watched his documentary today because you mentioned it in your email chain.
Yeah. So Accidental Truth, and it turns out Accidental Truth movie came out a year before James Fox's movie. I must say, I hope I don't want to piss off James Fox. I like him, but I like James Fox, and I also like, Ron James. But Ron James's earlier movie, Accidental Truth, is much better than Phenomenon in that it has a lot more it's better, visually, graphics. It has a lot of recreations, artificial, with CGI. The CGI is really good, and has a lot more detailed information on encounters, alleged, the dead evidence. It's much more detailed, and also has more detailed physics related stuff, even though it's physics, of Hal Puthoff and Eric Davis, which is I don't think is quite right, but it's
Fly models.
It has a lot had a lot of John Alexander, who's an asshole, but but what John Alexander says about some of the evidence, I do agree with that. It's just, my fight with John Alexander is purely political over Donald Trump, who's, of course, is now the president, the next president. So I won, John Alexander lost. And also with Eric Davis, my beef with Eric Davis was not what he says about the evidence. I agree. Yeah, we all agree. I agree it's real. I don't think Eric Davis is a liar about the Wilson memo or any of that stuff. I support what he says there. My disagreement with Eric is purely technical, on the details of the physics.
Yep.
The Al Puthoff thing, gravity, I think it's bullshit. But in any case, we kissed. Eric Davis, we gave it kissy. No, I mean, we made, and we agreed to cooperate because Eric does know things about what's happening inside the intelligence community. Or he's seen some, he has some kind of security clearance. He has seen things which I have not seen, but of course I have been seeing things that he hasn't seen either. And because it looks as though there's a chance, at least, that I'm going to be going to Mar-a-Lago, hopefully before the inauguration, and speak directly with the president and with RFK Jr. and hopefully Elon Musk. And maybe I'll get a chance to tell Elon Musk that he's a schmuck because he's putting all his eggs into rockets, and he should at least hedge his bet and put some of his money into what we're doing, control of the gravitational field of energy.
He's talked a little bit about warp drive in the past, but he has the conventional answer of it takes too much.
Yeah, right. Yeah, he doesn't. I could persuade Elon Musk in about 10 minutes.
I agree.
That's stupid. That's so. I just have to get to him because getting to these people is not that easy.
Yeah, it's the hard part.
And so I have several people who are close to the transition team, and Susan Wiles.
So you don't have to answer this question if you're not comfortable, but it's related to this. There's been a rumor going around that during his first administration that Jay Stratton and Ron Pandolfi gave him a briefing. Do you know if that's true?
Well, I know. Well, I don't know if specifically if it's true, and I don't know about. I heard to Jay Stratton. Now I know Ron knows him. Yeah, okay. And so I know. But the point is this: I don't know what they told him.
See? Okay.
Now the thing is that Jay Stratton does work with Travis Taylor
at Radiance.
Travis Taylor knows. I've been communicating with Travis. Me and Jose Rodal, the MIT guy. Travis had actually made a beautiful tweet back 2 years ago, December 11, 2022 tweet, Travis Taylor on X.com. And he summarizes
the universe.
He made a bumper stick. He summarized, he says, Control K and G equal KT and control the universe. And that's the Sarfatti theory.
Nope.
That's the Sarfatti theory that I gave at 2011 at the DARPA NASA 100-year Starship Conference. That's exactly it.
I guess this might be a good time to kind of go into a little bit of the physics, just for some people in the audience who aren't entirely.
Yeah, okay,
so I'll give you my rundown of my understanding.
Wait a minute. Can we share screen? Because I'm on an iPad. I can write directly. So how do we do that? Let me share. I want to get my screen. See if we can do this.
Okay.
Now tell me if you can see this. G mu. Do you see that? Equals 8 pi G C to the 4 over G mu nu. Now, can you see that clearly?
Yes. Now, traditionally, C is set to 1 in the weak field limit, but in the field of like quantum optics, for example, you don't set it to 1. You actually want to go off the epsilon and mu values. Is that correct?
Yeah, right. So this is it's this, right?
Yep.
This is Maxwell. Roughly 1865, right?
Yep.
In vacuum, okay?
Yeah, because that's vacuum.
I want to make my pen a little thicker. Hang on, let me make it a little thicker. Okay, so the point is, so you can see that clearly, right?
Yes.
All right, so here's the point. I'm changing that. So what we want to do is use C squared equals 1 over epsilon 1 plus chi E times mu 0 1 plus chi, I'll call it mu. Okay, chi c is the electric.
Near field, right?
Yeah, well, no, it's the electric susceptibility. Susceptibility from a basically dipole polarization. Right? Well, it's more than dipole, but I'm being oversimplified. Dipole polarization, and that's E. And the other one is the magnetic susceptibility. Of the material inside matter. Inside matter. Okay, so let me so basically what we have, this is in a simple case. G mu nu is gravity, is equal to 8 pi newtons G over, we'll have C vacuum, C to the fourth. This is just the vacuum value. But then we have 1 plus chi, I'll call it E squared. This is what, okay, E squared, and this is 1 plus chi mu squared, and then times T mu nu. So this is what I did at 2011 Orlando.
At the DARPA conference?
Yeah, DARPA, NASA, and General Pete Warden granted paid my expenses my way, to give the talk. Okay, so just like an officially sanctioned talk. Eric Davis was there. Eric Davis was present. Okay, but so now the point is this: anybody knows a bit of math, if these susceptibilities get big, suppose you want a fixed amount of gravity. There's a fixed amount of G mu nu that you need, say, to cancel the Earth's gravity, right? There's a fixed amount. So you keep the left-hand side of the equation fixed, and you increase, say, the susceptibilities by, it has to be increased by quite a bit, right?
Normally it's that, but you want to flip these and you make K big and T small, right?
Right, exactly, at constant G. That's the idea. That's the basic idea, right? That's the basic idea. And that's the basic idea I presented, what is it now, 12 years ago? Yeah, it's 12 years ago at DARPA NASA. And I also said, I said there 12 years ago, this is how the flying saucers work. And I mentioned in the slides, I mentioned with the metamaterials, these susceptibilities can get very big, because the C can get very small. Okay, the effective C. And that's, let's see, what else I say? I said a few other things, but, and I said it's got to be warp drive. It's got to be warp drive. It's got to be metamaterials. Up until that point, as far as nobody in public, at least, was saying that the UFOs are warp drive, and nobody was saying that that use metamaterials in the fuselages. I'm the first one, as far as I know, to actually say that in a public venue, because I discovered it myself. It's my own intellectual property. Okay, so are you there? What happened, Dan? You disappeared.
I'm grabbing a book.
All right. So now we have Louis Elizondo and all these guys. They're talking about stuff that I created, but they're not giving me proper credit. So I don't like that. All right, let's go. I guess they're stealing my intellectual property. They're trying to get government money and private money based on my discoveries and cutting me out of it. So
didn't Ray Chow come up with something similar to this in 2002?
Yes, but now that's Ray Chow and I working together. Ray Chow, yes, Ray Chow. But yeah, but you're right. Okay, that's Ray Chow.
So
Good.
there's this one
Wait,
paper.
but let me explain what Ray did and how it is. How it's not quite the same. It's how it's important, but it was a different context. Okay, Ray Chow. Okay, try to get this. Gravity permeativity.
Yeah, I think you're covering up the microphone. I'm having a hard time hearing you now.
Can you hear me now?
Yep.
Yeah, gravity permeativity. 2002. He's talking about Ray Chow is talking about detection of gravity waves.
And if he was basically saying that there has to be this
Sure.
gravity permeability if we can detect them.
Yes, they were saying that, and that corresponds. That basically corresponds to everything that Basically, he's saying that K is not the same as 8 pi G over C to the fourth vacuum. There's got to be, he calls it kg. Okay, his kg is what I call 1 plus chi e squared, 1 plus chi mu squared. Okay, but he doesn't have this. He doesn't. Okay, all he has. This is very important. The difference now. What he has is just a piece of the puzzle. He has kg, but he doesn't connect his gravity permeativity to electrodynamics. So he doesn't have this part. Also, he was not thinking about flying saucers or anything like that.
So what I was gonna say and what I grabbed my book collection here from,
Yeah.
there's 2010 paper from a Russian named Igor Somolyanov,
Yeah.
called Metamaterial Base of the Alcubierre Warp Drive, where he talks
Oh,
about using the dielectric permeativities and magnetic permeabilities. And this is in 2010. So obviously this is something the Russians are looking at too, which is a reason we should be putting more research into it.
okay. Now wait. That's very good. Would you please send me that paper? I never saw that paper.
Yeah, I'll have to send or find a copy. I'll have to send it to
Yeah,
you. Email
send
it.
me that paper. This
Yep.
is important. Okay, Leah, let's talk about the Russians. But that's real. I didn't know that. This is new information for me. So who's the guy? How do you spell his name? Spell his name.
Igor, Igor, I,
Wait, wait. Igor. Yeah.
I
I.
is the middle initial,
Yeah.
Smolyan, I,
Y-A-N or M.
Yan as in November,
Yeah.
Inov.
Oh my God. Okay. And where is he? Is he in Moscow? Where is he? What's his?
Oh, interesting. University of Maryland.
Oh, he's not. Oh, he's in
Oh,
Maryland.
he must be over here. Interesting. I didn't.
So is it archive? Is it on the arc? What's the title of the paper?
Metamaterial based model of the Alcubierre warp drive.
Oh, wait a minute. Wait a minute. I think all he's doing. Oh, no, 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 no. Okay. No, it's not. Okay. Here, this is a big confusion that everybody has. This is the confusion. Confusion. I think I'm right. Confusion of John Kramer. I think Kramer. Eric Davis. And Jim Woodward. Okay. No, I do know about this guy. Okay. This is the confused. They all got confused. This is important. Okay, are you listening to me
Yeah,
here?
I'm listening.
All right. Now look. This is using metamaterials. This is use of metamaterial. See, all these assholes, they get confused. To simulate GR. This is like put off. This is the analogy. how should we put? Okay, in general relativity. Okay, let's go through this. Okay, in some detail. In general relativity, you have ds squared is equal to g mu nu. This is the metric, not the Einstein, not the big G mu nu. Dx mu.
This is the line element.
This is the line element, right? For light, this is 0. That's called, for light ray, it's a null geodesic. Dx mu. Dx
those would be your 45-degree angles in a space-time.
Yes, null geodesic. So let's write that out in more detail, okay? Let's write that in more detail. So that's, well, are you able to see me, by the way? Because I can't see me.
Yeah, I can see you. Yep.
I can see me. Okay. So now let's write that. So we have 0, the equation of a light ray, light, is 0. I'm going to write it out. It's G00 C squared D T squared plus G0 I. I'll say 2G. There should be a 2 probably because it's symmetric tensor. Wait a minute. It's like this. Let's just do it. Since this is not for dummies now. This is for smarties.
You could write out the whole grid if you want. I can understand it.
Well, I mean, but it's not for the faint. It's not for mathematical idiots.
No.
D0I C dt dxi plus gij dxi dxj. Okay, where I is the space indices 1, 2, 3. That's space, and 0 is time. What the hell? 0 is time. Okay, so what you do, you divide. This is 0, so you divide everything. Okay, so this becomes 0 is equal to is equal to 1. I'm gonna divide everything is 1 plus 2 G0I G00, and I have dxi d dtc. Okay, plus gij G00 have a c squared dxi dt dxj dt. Okay, you see that?
Yep.
The speed of light. This is what they're doing. This is basically what Puthoff is doing, but he doesn't understand what he's doing. So you have C prime I. The components C prime are dxi dt. This is the coordinate speed of light.
So is Puthoff changing the vacuum speed of light instead of the material like you should be?
Puthoff and Davis are very confused on this. They've only done vacuum.
Okay, yeah, that's what I was asking. Yep.
All their stuff. They use a vacuum solution. They're using a particular form of the Schwarzschild exterior vacuum solution. It's not general. They never have matter. They don't know what the hell. What they're doing is just total crap. It's total inconsistent. But here's the point. But what this Russian, I want to explain what the Russian is. Forget about Puthoff right now. What the Russian is doing, he's see this thing, as you change the metric tensor components, it's as if you have it simulates. You can use the variation of the electromagnetic index of refraction in a metamaterial. You can use that. You can control those variations with electric fields and magnetic fields, and you can use that to simulate, to do an analog computer simulation of this gravitational field. And this, in particular, if you use the GI for the Alcubierre drive, in other words, you can use the controlled electromagnetic propagation of light inside a metamaterial. you can use that as a kind of analog computer simulation of gravity.
Okay.
But that's not what I'm talking about. See, it superficially sounds, they hear the word metamaterial, they hear gravity, and they're so stupid they don't understand what the hell I'm even saying. They don't, So this was a big red herring, a straw man. It was a straw man objection to and stupid James Woodward. He puts this false objection to my stuff in his Starship book, which is totally worthless because it's totally confused. They're all confused. All right, so that's that. So that's not what I'm talking about. In other words,
so they're doing a vacuum approximation, but you're turning.
they're using a vacuum. Okay.
Okay.
Well, it has no. What they're doing, they're using the analogy of the metric tensor in general relativity to the index of refraction in electromagnetism. It's an analogy. It's like a map. You can map the controlled propagation of light rays inside metamaterial with the propagation of light in vacuum in a gravitational field. There's like a one-to-one. There's a mapping.
Okay.
It's like the homomorphic mapping. Formally speaking.
Oh, you're covering up your thing again, Jack.
Formally, you can map. It's an analogy.
So they're making an analogy, but you're actually saying to turn K into a variable in the material, and that's how we get the.
Yeah, they're not writing this. They're only working with G mu nu equals 0. This is equal to 0. They're working with this. Okay, look, here's the thing. Suppose it's vacuum. Vacuum, right? And with gravity and vacuum, it bends light. Gravity, lensing. Lensing in vacuum. Okay, gravity lensing. But in a metamaterial, you can also bend light in a metamaterial. Here it's vacuum, metamaterial. You can bend light and you can control the path of the light ray inside the metamaterial any way you want. So you can imitate what light is doing in the gravitational field. So you see the idea so it's a mapping.
And this has to do with the scattering off the dipole moments.
Yeah, whatever. Yeah, this is just standard physics. But what they're doing, they're showing you can. It's like an analog computer. It's like CGI. You can control the shape of the light ray inside the metamaterial with external magnetic and electric fields. You can control it so that it looks like what light rays would look like in the Alcubierre warp drive metric. Okay? Has nothing whatsoever to do with what I'm talking about. And none of these big shots understood the difference. So they came out with, and Eric Davis had some, I don't know who it was, it says anonymous, criticized my 2011 work because the idiot did not know the difference that he was talking about, not what I was talking about. They're so stupid. All they saw was metamaterial and warp drive, and they didn't even know the difference in the math.
So would you say right now the only one who actually understands your work is probably Travis Taylor?
Well, Travis Taylor understands it, and Jose. Okay, who understands Jack? People understand. Travis Taylor understands it.
Jose Rodal. No, yeah, I think you're muted. Yeah, Jack, we're having some technical difficulties.
Yeah.
Oh, there you go. I can hear you again. Oh, and you're gone again.
Yeah. Okay. So Jose, Travis Taylor understands it up to a point. I'm not sure because Travis has stopped communicating with us because he's working with Jay Stratton and trying to get money from the government or from billionaire, who the hell knows. So he's kind of become a commercial competitor, it seems. But so he stopped communicating with Jose and I. But Jose Rodell understands it very well, and a few other people understand it. People we're working with, but Jose understands it very well. In fact, Jose, he's like an expert. He's okay. Jose is MIT.
I've read his papers.
Yeah, right. And what he's done, Jose has shown technical mistakes in the Eric Davis paper. Eric Davis did a paper with a bunch of people at Baylor University on very important on what are called curvature invariance of the Alcubierre warp drive. Yep. And you got to give them credit because they at least saw the problem. They saw it was an issue, and it's a good thing. But their execution of the Mathematica program was inaccurate, and they made a big numerical mistake. And Jose Rodal went in and corrected it. And guess who? Stephen Wolfram saw it, and Stephen Wolfram got in touch with Jose Rodal about, and I think Wolfram has asked Jose Rodal to give a lecture to the Mathematica people because Wolfram liked, how Jose Rodal made the calculations of Eric Davis much more accurate and corrected, gross. It's a technical, it's computational.
Yeah, he also found some issues with the Notario solution too, didn't he?
Yes. There's all kinds, and he's working. Yeah, he's doing all kinds of stuff now that I'm not going to say more about it. One, because I don't understand it completely, because I've been doing my own stuff, and until he publishes it, I'm not going to say more. But Jose Rodal is like he's the top guy now in computational relativity connected with warp drive and UFO propulsion physics. That he knows that. He's like Kip Thorne. What Kip Thorne is to conventional general relativity right now, Jose Rodal is.
That's going to be important when we have to start building our ships, because we're going to need AI to run the real time.
Well, not only, well, of course, because we'll get to that in a second. Not only do you need AI to navigate the ship, you need AI to design the metamaterial. We don't know how to make the metamaterial yet. Okay, NHI has it. Okay, so and the point is this: the ships, the UFOs, are conscious.
Yep.
AI.
An analogy I've used like this in the past for people is like if you've ever worked on like an old fighter jet and you tear off the dashboard on the cockpit, it's all electronics and avionics. There's no wasted space whatsoever. And eventually everything goes solid state, and all this is going to get fully integrated into the fuselage as one big AI.
Yeah. Okay. In fact, yes, that's right. In fact, it's all nanotech. Nano.
They're probably going to end up needing to use some type of like vapor deposition to even make the thing or something like that.
Well, I don't know. That's for other guys. Those are details I don't. They're important, of course, but it's not anything that I'm going to contribute to. That's why you need Manhattan Project 2.0 to do that. Yeah. That's correct. But now, what I want to say about that, the inside of the Tic Tac. Let's say, if you got inside a Tic Tac, it's pretty much empty. Everything is in the thin metamaterial fuselage. It's all nanotech, nano and micro, at least micron to nanometer. And according to Eric Davis, who does have some access to some classified material, Eric Davis has said it goes down to like the angstrom level, maybe even. Nothing. We can't get down that small. Okay. Where's the Apple? The Apple M3. Apple as M3, M4. They're down to what? 3 angstrom? 3 nanometers. Okay. Now we can modify. In principle, we can modify the M4 chip to make it conscious AI.
Well,
Conscious.
that's one of the things they've had in some of these crash material fragments where they seem to be these layered kind of
Yeah, but that's all bullshit. Yeah, I know. That's
bullshit.
all. Yeah, pretty much bullshit because they haven't done. This is what the bismuth, the BI, or what is it, BI?
There's a few
Yeah,
different
okay,
ones.
stop
That's one
that.
of
Yeah,
them.
what happened here? What did I do? The BI is it MG stuff?
I think it's
Yeah, yeah,
bismuth, magnesium, and zinc.
yeah, whatever. Yeah, the stuff that put off and all these guys talk about. The point is, they've had it for years. They haven't done anything with it. They haven't, yeah, they have some weird isotopic ratios, but bullshit. They haven't done anything. It hasn't led to anything useful yet, or at least maybe it is, but it's classified. But the point is, I already know that we have functioning alien craft. You don't need pieces of it that actually work. That that
So
that.
in
Wait, did you hear what I just said?
yeah, we have functioning credit, and what I was going to ask, does this have to do with the so I think it was like back in the 70s. Wasn't it didn't von Braun, wasn't he the one who got the funding for like the SRI program and the CIA to study some of this stuff?
I don't know. I have no idea. Yeah, I don't know anything about that. I don't know directly about that. But what I do know is I know that these machines, the intact flying saucer, it's like 10 meters across, and it weighs about 3,500 pounds. And, who talks about it? Rick Doty and Phil Corso.
So you got recruited by the CIA to work on consciousness and how UFOs work 50 years ago, right?
Right, right. And
Not
also
where
this, both two problems: conscious AI and flying saucer propulsion.
well, because they're related.
They're two sides of the same coin. Yeah,
Yes.
they're totally related. Which is why that asshole from CERN, I don't even remember his name, he wanted to break it apart right away. He's an idiot.
So
Schmuck.
how do I want
He's
to
a
ask
schmuck.
this?
He's a schmuck. In my black book, the guy's a schmuck. But yeah, because it's what it is. It's ER. Oh wait, I gotta be careful with my hand. It's ER equals
EPR.
EPR.
And you
When
worked
it's
on this with Lenny back in the 70s, right? Or
well,
this
here's the
is
thing. No, here's no. This okay. Now we're getting upon the high straight. Lenny Susskind. World hologram. World hologram.
so I want to get into holography.
Yeah,
But
yeah. Well,
before we do, can I ask one question? God, that's tied into that you working on this stuff for the CIA years ago to figure out how UFOs work.
yeah.
If you had firsthand knowledge or access to such materials, would you consider contacting Arrow and their whistleblower program to give them the proper information?
I'm not sure what you're asking me. What?
So if you had more information that you need to be careful with about these UFOs that we have,
Yeah.
would you be able to go to Arrow under the new Whistleblower Act?
I don't know. It's too hypothetical for me. Here's the point. I never signed any NDAs.
Okay.
Okay. The only NDA I signed with any official state was with the British. I've signed the Official Secrets Act in 1960s because I was working at Her Majesty's Atomic Energy Research Establishment at Harwell. Okay, and it had nothing to do with UFOs. Well, it did in a certain way only, but not explicitly, because I was working with a guy named Marshall Stoneham, who since passed away, sadly, and on what's called the on-teller effect, and it had to do with the application of basically the Goldstone spontaneous symmetry breaking in condensed matter physics, which does play a role, but nobody, we weren't thinking about UFOs back then. So basically, when the CIA, Zolan, How the Hippies Say Physics, David Kaiser's book, when the CIA basically recruited me to work on this, I was obviously part of some kind of like a legacy program where I was going to be outside the establishment because then I would be unfettered, completely unfettered, not have to worry about all this compartmentalization, okay, which has hamstrung everybody, which is why the United States has failed to understand the phenomenon. Whereas the Russians, I believe, are way ahead of us in this phenomenon. Okay, which is, the Russians invited me to Moscow last year. I didn't go, but they know the Russians are tracking this stuff. I was told that Vladimir Putin himself has a personal interest in this work. His whole field. Putin himself. So that's why that's why I have to get Trump, you know, in on this because he better know what Putin and what the Russians are doing. Nope. Because right now, okay, the Russians have superior. Russians, okay, we cannot win a war against Russia right now. We cannot win a conventional war against Russia.
Yeah, they have hypersonics.
Yeah, they have hypersonics. And why does Russia, which has 1/10 the defense budget of the United States, they have hypersonic missiles and we don't? Why do you think that is? Because we have a bunch of greedy, incompetent assholes in the military-industrial complex and at the four-star and admiral level in the Pentagon, going back and forth, making a lot of money, stealing $1 trillion a year from the American taxpayer. And now, when Donald Trump gets in with Elon Musk and Vivek, they're gonna get that money back. They're gonna take. I mean, if I have anything to do with it, I didn't do it. They're gonna get these guys. They're gonna prosecute them for fraud against the American people. They're gonna confiscate their assets and give the money back to the American taxpayer because they've totally screwed America. Vladimir Putin. I mean, Russia was on its knees in the 1990s. And Vladimir Putin took Russia and now made it more powerful than the United States on 1/10 the budget. They spend 1/10 and they have 10 times better equipment than we do, as proved by the crap performance of our weapons in the Ukraine battlefront on every level. The Russians are superior. They're superior technically. And not only that, they have a lot more equipment than we do. They have a lot more ammunition.
So
okay, this is a side issue, but so the point is, the United States we've already lost the arms race.
Well, I don't think it's a side issue. I think it's very much to the point that we need Jack Sarfatti to tell these guys to do warp drive.
Exactly.
We need the next big thing.
Exactly. And if these assholes don't get that, then they're going to go down. I'm sorry to say, Russia has won the war in Ukraine. Russia's won. And, and partly Russia's won because not only are the Ukraine, at the beginning of the war 2 years ago, the Ukrainian army was pretty damn good, pretty strong. Okay, they had a lot of men, and the Russian army was fairly weak. It wasn't that good. But the Ukrainians have made so many tactical and strategic errors that it's almost as though the Ukrainian generals are working for the Russians, that the double agents. It's the only it's the only thing I can think. Or it's also I'm told it's because the British idiots and the French idiots and the NATO people were telling the Ukrainians to do all these aggressive measures when they should have done what the Russians did, which is what's called aggressive attrition. Build your marginal lines, the concrete things, and just put like a war in place, like the Russians did. In any case, the war is lost. Never had a chance. And the idiots now around Joe Biden, the neocons, they're in the last 8 weeks we have left, they're trying to start World War III, which will lead to a nuclear war. And we're all going to be dead unless the NHI, time travelers from the future, stop it because they're able to neutralize the nuclear weapons, right? We all know about Robert Hastings and all that, right? Yep. So that's our only chance of surviving because these idiots, these crazy lunatics in Washington and in 10 Downing and in the Ministry of Defense and in the palace, the Elysee Palace in Paris, they're trying to get us all killed, including themselves. They're crazy.
So this is lunatics. This is an opinion that's gotten me some flack among some physicists.
What?
It's that warp drives aren't a physics issue anymore. If you actually follow the science, it's an engineering issue.
Yeah, well, that's what I say. That's what.
And
Yes.
that we're on the same page in that, what do you think it would take in order to get a working warp drive?
Well, the point is, we already have a working warp drive. We just need access to it. What I have to do, I have to talk face to face with the President of the United States, Donald Trump. And I'm from New York, and he's from New York. I'm a little bit older than him. We have similar personalities. I can talk to Donald Trump, and he would immediately see what I'm talking about. And Trump has to then basically put Sarfatti in charge of the whole fucking program and just declassify everything, and we'll get it done very quickly. Remember, my professors built the atomic bomb. I was trained by the guys, Hans Bethe, worked Oppenheimer's A team. So put the A team in. They've been using the B team. Hal Puthoff, all these guys, they're the B team. Yeah, they're good at certain, but they have a low glass ceiling.
Need to
Now
put
it's
the A
time
team
to
back in charge.
put the A team in there. So all I have to do, I hope that Ronald Pandolfi from CIA, I hope Jim Angleton, maybe now Ron James is connecting with Senator Gillibrand. So this is
Oh, good.
bipartisan. I'm not, I'm an independent. I'm not a Republican. I'm not a Democrat. Okay,
Same.
and we have to end the cultural civil war, and we have to, a house divided against itself will not stand, right? And also, Russia is not our natural enemy. That all that Russophobia is bullshit. The whole false narrative that Putin is Hitler, all this nonsense, that's all created by these war criminals in the Pentagon and in the military-industrial complex that have created this false narrative in order to justify stealing $1 trillion a year. Why do you think we're $36 trillion in debt? Because of these greedy assholes. They're the ones. Fuck them, man.
No, I've said for
All go to
years we'd be
jail.
better off
They
working
should be.
with the Russians instead of against
What?
them. Oh, I've
Yeah.
said for years would be.
Hey, Russia. You know what Russia is today? It's not the Soviet. Russia today is the United States in the Eisenhower in the 1950s. They're Greek author. They're Christian, but they have like 200 nationalities. The Muslims and the Russian and the Christians are working together. They don't have all this woke DEI, cancel culture, anti patriotism, transgender bullshit that's tearing us apart.
So did
So
you see Leonard Susskind's recent interview where he says that string theory and ADS is dead?
yeah, no, yes, I know. And Lenny is correct. He's an honest man. But the point is this: see, the string theory is not totally dead.
Well, there were
ER
some good
equals
things that came from it. Like ER equals EPR is one of them. Something that he said that I both simultaneously agree and disagree with is that we
what's
need to
that?
be looking more at de Sitter space instead of anti,
Yeah. Okay, but wait, that's
where he
cosmology.
was where I think he was wrong is where he says that nobody's looked at de Sitter space models yet, and that's not true. There are people
Oh,
who have.
wait, stop that. It's what you're saying is important physics. It's not the physics we're talking about. It's not relevant to right now. It's cosmology. It's important stuff. I'm not saying it shouldn't be done. I fully agree with Lenny says there, okay? But it has nothing whatsoever to do with the immediate problem of not getting into a nuclear war with Russia and figuring out how the NHI, the alien tech works.
I was trying to relate it a little bit more back to EPR and holography, but
Okay, now wait a minute. Stop. ER equals EPR applies in low energy condensed matter physics. It's not just cosmology.
yes.
The idea is that's what I'm talking. That's what I'm talking about. The ER. Let's get back to this now. First of all, guess who first had ER equal EPR? ER equals EPR. Jack Sarfatti. Sarfatti, 1975. Book Space, Time, and Beyond. Space, Time, but that's a whole story, okay? But in primitive form. I didn't have I did not have ADS CFT. I didn't have that kind of the math. That's what Lenny did later. But basically, I had that there had to be a I had the idea that for every quantum EPR entanglement, for EPR, that there was a little wormhole there. The
Yep.
wormhole. I had that picture. I had that picture very explicitly.
And that can
Okay.
explain the non-locality.
Yeah, yeah. I had all that. Okay. And it was though it was I it, since Lenny Susskind and I worked together at Cornell in 1963, our EPR entangled minds, we have a subconscious telepathic connection, and so in 1974 or so, I was having a precognition. Jack is having Lenny. What? Jack. Whenever he did it, I mean, when did he do it? Do you know when World Hologram Paper was like 2005 or something? Whatever it was, say 2005. I don't know.
I'm not sure the exact year off the top of my head.
Yeah, yeah, and Lenny, but it was years later. So I was having precognition of Lenny's future physics, of Lenny's discovery. So I'll give him the credit because I had a very primitive idea. My signal to noise ratio, was low. I mean, I had some of it. I didn't have all of it. Okay, I didn't have
Well,
all.
I think there's an old saying in physics that things are often named for the last person who discovers it.
Yeah, yeah. Well, I had the basic idea. I had the physical, the intuition, the physical picture. So the point is that EPR.
Now, was there something that Hans Bethe said to both you and Lenny that might have provoked that thought?
No,
No? Okay.
no. No, the Cornell, they didn't know. No, I don't think Hans Bethe. I don't think he knew about EPR.
Okay.
You're able to do a lot of physics without it. Nobody at Cornell in the 1950s, early 60s was thinking about quantum entanglement. I knew about it because in 1958, I read David Bohm's quantum theory book where he talked about EPR. And they didn't know what the hell I was talking about. Even at Brandeis. So no, I mean most of the nuclear physics creating the bomb, you don't need ER because you don't need entanglement. I mean it's there, but it's covered up. It's the Pauli exclusion principle. But they didn't really need it. It was only much
first,
later.
was it 1935 when they first thought of it?
Yes, but nobody doing practical physics of the
Nobody
war.
was applying it.
Nobody was conscious of it really. It laid in the backwater, and this is what the whole book had to be say physics. David Kaiser, MIT, said it was Jack Sarfatti and his friends, Nick Herbert and all these guys, and with John Clauser. But we're the ones who Clauser independently knew about EPR. He was doing his experiments, but we're the ones who made a big stink about it and got everybody thinking about it. Even trying to explain consciousness.
Didn't
all right.
Wheeler kind of play with the idea too a little bit?
Oh yes. Well, let's see. Did he actually?
He was weird. He bounced back and forth on
Wheeler
the ideas.
actually. I don't think he did. No, he had delayed choice. He had local retrocausality. Because he had the wheel of Feynman advanced. He had that. I don't think. I'm trying to remember now. He never really does. He. I'm trying to remember. I don't think he really.
He was the one who coined the term wormhole. Before him, they were called Einstein.
Yes, no, he had wormhole, but he didn't connect it with entanglement.
Gotcha.
Yeah, he had the wormhole, of course. I mean, the reason okay, now listen, that's what Jack Sarfatti did. That's what I did. Because number one, I was working with, I knew Wheeler. I communicated with Wheeler. I was physically with John Wheeler and Werner Heisenberg in 1966 at the Max Planck Institute. Max Planck.
So what years were you talking with Wheeler?
In the 60s, 1960s.
Okay.
1960s. But then in 1971, I was with David Bohm in London. Okay, and then in 1975, actually 74, I get ER equals EPR because that's Wheeler. And this is Bohm. Because Bohm was working with Einstein when he did that. At Princeton, 1953. Yeah, so it's all connected. So I made the connection in 1974. It's in the comic book Space Time Beyond, which sold a lot of copies and influenced all kinds of things, including movies in Hollywood. It's like a cartoon book. So yeah, and that's what David Kaiser, how the hippies say physics.
I read How the Hippies Say Physics. I haven't read the other one.
What's the other one? There is no other.
Yeah, your space time and the 19.
Oh yeah, that's comic book. Yeah, but David Kaiser mentions it in his book. He mentions it. And then there's also the Nova. There's the Nova thing. I'm in that, but they don't mention my name, the assholes. The Nova on Einstein's riddle. PBS. Einstein's riddle. I'm in it. You see my picture. I'm in it.
So where this stuff interests me in relation to warp drives is I've had the opinion for a while, especially after reading a few papers, is that warp drives are really what's a clever word we can use here? Entanglement escalators, maybe for perhaps they're more of an entanglement
You may be right,
device.
but you have to show me the math. Yeah, they may. I don't understand what you
So
just said,
I sent
but
you
there may be something there.
I
What?
sent you a paper a little while back by Yuri Eroshenko, who is another Russian physicist.
Yeah.
It's a 2021 paper called Escape from a Black Hole with a Spherical Warp Drive. And in
Oh
it
yeah.
comes
Okay.
up with
Yeah.
the
Oh, yes.
he comes up with the WD equals EPR conjecture.
Yeah. Okay. Yes. And the thing is this. Yeah. Well, if you could bend the light with warp drive, you can get through a black hole through an event horizon. Sure. Yeah. Yeah. Yes. Yes. Yeah. So to that extent, yes. But I have to see the paper. Yeah.
I can send that to you again. And then the other bit that I think is somewhat related to your work is how more recently the whole entropic gravity thing, how people are getting uh they're deriving general relativity out of
Yeah. Okay. Well,
entropy.
so okay. Now this has to do with Ray Chow. Ray Chow's. This is the main idea. Look, you have. Okay. Let me try to be specific here. G over C to the 4 has the same dimensions. Let me get this right now. As E over MC squared. Yeah. Okay. Squared. Right. Okay. Where E is the charge on the electron, M is the mass of the electron. They have the same dimensions. I'm not using. I may need a 4 pi epsilon 0 in there, 4 pi epsilon 0, whatever, because
It's energy
but
over
in
heat, right?
SI, it depends on the unit system. But there's basically GM squared over H bar C and E squared over H bar C are dimensionless, pure numbers. Okay. And here's the fine structure constant, right?
Yep.
And in SI units, it's a 4 pi epsilon 0 there. I'm being sloppy about that.
It's
They're
Straussian.
the same dimensions. They're the same dimensions. Okay. But the problem is that this is scale dependent. And this is the dimensionless coupling of gravity. This is like okay. This is like let's see, what is the square? Okay.
Well, because G divided by
Okay,
the C
wait.
to the fourth or C is
Okay,
that's
wait. Okay, let me just talk here. So this is a coupling. This is like if you have a Feynman diagram, if this is a photon, okay, and this is an electron, and this is like an electron, E minus, E minus. That's called the vertex function, the vertex, pair vertex. in the Feynman diagram. Okay, the coupling is basically this. Okay, that's quantum electrodynamics. So if you want to do quantum gravity, roughly speaking, can you see me?
Yeah.
Quantum gravity. So what do you have? You have a graviton. This is a graviton, and you have some kind of mass, some kind of mass. But the problem is that the coupling will be something like the let's see, it's G.
So are you talking about the coupling?
Okay, the coupling. Wait, the coupling is going to be the square root of G over H bar C times M. The coupling itself depends on M, and that's a problem. That causes it's the renormalization problem. Renormalization. This is you get infinities, all the infinities. Okay, there are problems there. That in other words, the coupling is scale depends on the mass. The mass is the energy scale. So all right. So here's the thing. Ray Chow. Let's see if I can. Ray Chow has this idea that if you had a bunch of spins, these are electron spins, and they're EPR entangled. EPR current. They're entangled. Okay, they form a collective, like entangled system. He thinks that will amplify the effective coupling between gravity waves, gravitons, let's say, and converting into photons.
It sounds like the Gartenstein effect.
Well, it's related to that because it's that way. So a graviton has spin 2.
Photons are spin 1.
Photon has spin 1. So that means you're going to want to, like, if this is the coupling.
Yeah, there's a resonant coupling.
Yeah, so there's like a spin 2, and you need graviton, and spin 1 photon, spin 1 like that.
So this
photon, but now the idea is that he thinks this coupling is what's called the gyromagnetic ratio. This coupling depends on E over M. Let's see, E over M. It depends on E over. But let's see, the coupling goes as it goes as E over MC squared. Okay, so it's going to go like the coupling goes E over MC squared sort of thing. Okay, so that's his idea. But that the point is this: for the electron. Okay, let me put it this way: G over C to the 4. The usual Einstein coupling, G over C to the 4 is going to be like
10 to the negative 43 newtons.
Yeah, 10 to the minus 43 reciprocal newtons.
And that's the inverse of the Planck force.
Yeah, the inverse of what Sal Pais calls the super force, but he says bullshit.
I don't like that name.
Yeah. All right. But so this would be E over MC squared. I forget the exact number. It's roughly like 1. It's a lot bigger. Okay, it's a lot bigger. So the rough idea, I forget exactly if it says. I think it's 10 to the minus 1 newtons. I think it's 10 to the minus 1 newtons to the minus 1. I think it's a factor of 10 to the 42. But in any case, a lot bigger, tremendously bigger. So that's roughly the idea. That's why Ray Chow thinks that using the electron spins, the gyromagnetic ratio of the electron spins when they're entangled with each other, will amplify the coupling Yeah, like a Gershon effect, will amplify the coupling of electromagnetic photons to gravitons for what's called the far field. This is far field. Any case, so to make a long story short, there's now a company called Texas Space. Can you see it? Texas Space? Space in Dallas. Guy named Juan Faria. And they have a patent. They've gotten a patent on Ray Chow's spin gravity, the spin. Let's call it spin gravity.
So can I interject here for a second?
Yeah, yeah.
So this is reminding me a bit of Maya Benowitz work. Now, there's a reason why the connection doesn't seem obvious at first. You shared one of her
Wait.
tweets.
Let's go slow. Let's so people. Maya. Damn, I can't. You should. Benowitz. Now, where is she? She's in Maryland.
So she's in Minnesota right now
Oh,
currently.
Minnesota.
But she just got an offer to become an undergraduate in Canada under Dr. Nyash Sarfatti at
Undergrad or graduate student.
or yeah, she's for a PhD program. She got invited
Yeah,
to
graduate. You said undergrad. Yeah, graduate. Yeah.
at the Perimeter Institute up in
Oh,
Canada.
really? At Perimeter?
Yep. So
Okay, that's interesting.
under Nyash Sarfatti.
Oh, really? That's
Yep.
good.
Yeah. So she's been busy with that.
Oh, good. Now
Um.
remind me again what she did, because I remember she did something interesting.
So, and I've
I'm
kind of
having my.
so
Go ahead.
you shared a tweet a little while back, and you said that she did good work.
Yes,
You
yes.
see now that it wasn't directly related to what you were doing.
Yeah.
Now, I think the reason that is A, the paper you shared was an obsolete version of her paper from 2018. She has a new one from this month that I've kind of been helping her with on the side. Um,
Tell
and
me what it's about. What's the title? Let's write it down. Write it down. What is it?
it's a theory of the universal wave function and the origins of the cosmos. Um,
Oh yeah, she's doing cosmology. That's I
well,
remember that.
so let me build the connection here because it's not
All right.
obvious. It's not obvious.
Okay.
She uses a very poor choice of notation in her bulk equations that makes it seem weird. It's her EG, EB, and GG fields. And so what are those? Those are the coupling strength between the spin 1 and the spin 2 fields.
Oh really? Oh, she has that kind of stuff. Okay.
Yep. Yep. So she has a full bulk equations of motion because hers is it's a de Sitter space holography. Um, where you
Oh
have
wait, but that's vacuum. That's not material. That's vacuum, right?
and she caveats that in her appendix where she says it's an approximation and she's setting C to equal 1. We're gonna do a different paper later where we go into more detail.
Yeah, but I'm trying to get the idea. If she's doing cosmology, then cosmology is basically vacuum metrics on a large scale, right?
So her thing though
It's
is
vacuum.
she so the her whole research program is trying to build up equations of motion from the least amount of axioms, the least amount of assumptions going into it. And so our guiding principle is quantum covariance, Everett's principle of quantum universality. The wave function is representative of reality at all scales. There is no Heisenberg cut. Um, and
All
so
right, but wait, that's quantum mechanics. Where does general relativity come in?
because general relativity is emergent in the
Oh,
bulk.
she gets its immersion. Oh, she gets its immersion from the wave function. Well, I don't know. That's pretty good if she can do that. Yeah,
So
there was I did see. Yeah, I saw enough of her stuff. It's not directly related to my thing because number one, she's dealing with cosmology where a point in cosmology is like like a parsec or something, a couple of parsecs. I forget exactly. So, but I'm dealing with, with nanotechnology, with condensed matter
Well, no,
physics.
so if you read she does make some small scale predictions as well.
Right.
So she's going for a theory of everything. Whether or not it's correct, we'll see. She has made some correct predictions already, though, at least in the realm of cosmology.
All right. Okay. But you know what?
In terms of small scale particle physics,
Let's stop. I'm trying to stay focused on a very practical engineering military problem of this technology to prevent the nuclear war that we might have next week. Okay. And so the point is, we're living in a very unstable environment. I'm sure her work is very good. If it provided we don't kill ourselves before January 20th, none of us may be around. She would be all dead.
so
Okay.
in
You
terms of
okay?
small scale predictions that she
Yeah.
makes is she doesn't believe that the future of particle physics is bigger and bigger particle colliders. No, really, what the future of particle physics is and this is because the gauge degrees of freedom are not redundant, even though we're taught that they are.
All right. Look, this
That
is
it's
all good
actually going to
stuff.
be it's going to be compact antimatter colliders.
I'm not saying she's wrong. I fully, provided we don't have a nuclear war and we're all alive in a couple of, I think she should go to Perimeter Institute, get her PhD, and keep working on this. I'm all for it. I support that. But this is a digression. It has nothing to do with what I'm interested in right now. I want to stay very focused on some very practical issues. Okay. So, and this is, so what? All right, there's a lot of good physics being done by a lot of young people. I fully support it. But right now, none of them may be alive in a few
And
months.
the
All
I
right.
guess my long-winded connection is that the two things at the end version of her, she wants to do tabletop warp scale tests that we can prove in the lab. And then
Well,
there's
how does she get? Well, that would be great, but how does she get from cosmology to warp drive? I don't see.
because so we need the cosmology for navigation because her theory predicts that you're going to have a Bohm-Aronoff like variations and observer dependent variations in the CMB background, and that we're going to need to use these for
Oh,
superluminal
listen,
navigation.
okay. That's fine. That's good. Yeah. Okay. There may be some. I'm not. Yeah. I'm. That sounds pretty interesting.
Like I
That'll
said,
be ultimately important. But right now, we have to figure out how to first build how to replicate the technology. Oh, but remember, these NHI, they already have all this. They have all this. It's already operational. So if anything, if she gets it, it's because she's channeling. She's a contactee, and that's telling her how to do it. Yeah. So I see. Yeah. But that's not important right in the short term. That's
okay, I can
definitely
agree with
important
that.
in the long term. Yeah. Definitely important in the long term. Right now, don't you understand? Right now, I want to get, and I don't know if it'll happen, but I would like to happen if it's meant to happen to get to Mar-a-Lago before Trump is inaugurated, and to talk to them and get Trump to declassify all this bullshit that's preventing us getting this technology. And I could probably sell it because the Russians are already way ahead of us on this thing. So
I agree.
so all we're doing is hampering ourselves. We're doing exactly what the Zelensky in Ukraine and Sersky in Ukraine, they've destroyed their own army with stupid
Okay,
tactics. And
so
we're doing the same thing here.
getting back to kind of more into your stuff then and
Yeah,
the laboratory application of this, when I'm reading your equations and I'm playing with them in my mind,
yeah,
what I see is that because we're playing in matter and not in a vacuum anymore,
yeah.
the Schwinger effect should actually be at a lower energy than in the vacuum.
Now, yeah, that may be so. Yeah, yeah. In general, I think that's roughly true because what happens since the swing effect. What is the equations again?
The, the
The threshold energy may go down in metamaterials. Yeah, that may be right, but I have to double check that. I don't remember off the top of my head, but I think what you're saying is generally is on the right track. Yeah.
So did you
Things.
when you were in Paris, I mentioned earlier this year that there was a lab that claims to have gotten a mesoscopic Schwinger effect in graphene. at 10 to the 7 volts per meter instead of 10 to the 18, which to me would seem like an authentication of your theory.
Okay, yeah, you may be right. Okay, that's good. I don't remember that. That's good. It's a little swing effect. Hang on. That's very, very interesting. Let's say. Yeah, that's very can you okay, send me would you send who yeah, what's the reference to that paper? That's important. Yeah, you're right. If they get that, that is the lines, but they're doing very high energy.
Parametric amplification of a superconducting plasma wave. No, but I'm close.
All right.
Complete stop and dispersion its light and plasmonic waveguides. Nope, that is not it.
All right. Listen, I think we're losing audience here. But this is something, please send me that, later. I don't need the information right now, but is it in the metamaterial?
It's in bilayer graphene, so in the Dirac wells
Oh,
of
yeah,
the quantum lattice is where they're getting the pair production.
Sure. Okay. Yeah. Well, let me just see. Where the hell is the basic equation for the Schwinger effect? 314. Wait. Let me just see. I'm looking up Schwinger effect. Oh, that's good. Guess what?
What's that?
As the speed of light. Okay, the Schwinger pair production in a constant electric field takes place constantly. The rate of the effect, which is what we want. We want that rate to be big, right?
Yep.
And we want the rate to be big, and it goes as c cubed in an exponential. So as c gets smaller, the rate gets bigger. That's good.
So do you see the connection that I was kind of seeing there when I was looking at your equations?
Yeah, as c, I have to look at it again, but it looks as though as c gets smaller, which is the effect I want in warp drive, I want c smaller inside the material. The rate, the Schwinger effect rate gets bigger. That's interesting. Yeah, I got to think about that. Okay, I got to think about that. Let's the Schwinger. Let's see what's the Schwinger limit. The Schwinger
10 to the 18 volts per meter.
Oh, good. Perfect. This is good. We got it. The critical electric field is proportional to the cube of the speed of light. Yeah, the third. And so as it goes down as the cube. That's pretty good. That's good. That's very good. And the magnetic field goes down as c squared. Yeah. Definitely. You're right. That's correct. What you're saying is correct. Definitely. Interesting. Oh, I guess this is very okay. Listen, edit this, okay, and make sure you edit out the noise. All right.
Okay.
This is very good. This is extremely good. Listen, this could lead to some money because it has very practical applications right now. What you just did. And we should probably stop. Is there anything else? This is good. This is a good stopping point. Unless there's something else that you think is really important. But
if you want to stop here, we can stop here. And if you want to do another one in the future,
we'll do another one. We'll do another in the future. Is there some other pressing thing that you wanted to bring up that
not without getting into a whole nother big thing.
Area let's wait.
Let's is one thing. And then I wanted to get into retrocausality, but we can do
let's do that another time. Let's do that another time. But listen, let's focus on this. When you write this up, put the equation. Go to Wikipedia and just show the way the speed of light depends on how the speed of light comes in the equations for the Schwinger effect. Okay, and then just basically put in the index or replace c by c over n, where n is like an index of refraction, and see what happens. Okay. No, that's good. We're getting a low energy for that's exactly correct. And that is related to the warp drive problem. Yes.
Yep. Yeah. And so I think graphene is a good substrate to use for a lot of this, but I could
but graphene is just we're gonna make graphene like artificial it's a meta surface.
Yep.
Make a physicist. Yep. Okay, good. So edit this. Okay, try to put in some graphics. Okay, try
Okay,
to
I can do that.
write the equations properly and all that. Because okay.
Alrighty.
All right. Okay. So yeah, let me know when you have it ready. Okay. Good.
All
That's
right.
very good. All
Thank you
right.
for your time, Jack. I do appreciate it.
Yeah. No. No. This is good. This is good. Okay. Bye.
All right, bye.
Okay. Stop. Okay.